So this one is classified paper 6. The topic rate of cooling experiments. So we'll discuss how rate of cooling experiment simply refers to you have a hot water, how much time it will take to cool down, and you measure the temperature change for every 30 second with 3 minutes for 3 minutes and 30-second interval to work out how much time it will take to, and you can sketch a graph between the temperature and time and compare the gradient or the slope to work out the rate of a cooling. So some students are investigating how the volume of a water affects the rate of a cooling, rate at which the water cools in a beaker. Like we are changing the volume of a liquid and investigating how this amount of a liquid can affect the rate of a cooling or how much time it will take to cool down. In the question, 200 cm cube of a hot water was poured into a beaker and initial temperature rise. The value is shown in thermometer A. In a first row of a table, record what is the initial temperature here for thermometer A. What's the initial temperature? 87.
87.
And what is the initial temperature of thermometer B?
89.
89. So what they said? They said that write these values in a table. So we will write 87 and 89 here. So this was 87.0 and this one is 89.0. Because you should use same number of decimal place or significant figure when you're completing a column. The next one, what student did, the temperature was recorded for 30, 60, 90 and complete the column heading. So column heading means the units. What is the unit of a time? So second. And unit of the temperature? Yeah, degrees Celsius. And then you have to complete a time column. What is the time column here? So 30, 60, 90, 120, 150 and no, it should be 150 and 180 because in the question student recorded the uh, yeah 120, 150 and as they mentioned here 120, 158. So it's like recorded for 3 minutes. Then describe one precaution which should be taken ensure the temperature readings are accurate as possible. So whenever you're doing for rate of experiment, like you're doing an experiment which is related to rate of cooling, two precautions should be there. Number or two or three precautions. Number one, you should look perpendicular and avoid a parallax error. That is one of them. The thermometer should not touch the base or the wall of the container or a beaker. That is another one. And the third one, we allow the temperature to rise to certain value. Like we will stay with the thermometer and wait until the reading stop rising to record the initial temperature. So the three precautions related to this experiment are, number one, the parallax error, look perpendicular. Number two, the thermometer should not touch the base or the wall of the container. That is the second one. And third one, we should stir with the thermometer. Because in a liquid, the uniform transfer of heat, it's not like it takes time to transfer the heat energy as there is a convection. So you can stir with the thermometer and record the temperature when it stops rising. Like when it reaches the maximum value, that moment you will. So stir with thermometer and record the temperature when stop rising. So three precautions we should take. So any one you can write here. Any one is acceptable out of three. Then write a conclusion stating how the volume of a water in the beaker affects the rate of cooling and justify your answer with reference to your result. So as you can see here, this was an experiment. So this was an experiment. Which one cooled down faster? Can you identify from these results? What is the temperature change for 200 cm cube water? How much is the temperature change in 180 seconds?
9.5 degrees.
So this one is 9.5. What about the temperature change for 100 cm cube beaker? 100 cm cube of water.
14.5.
So 14.5. So which one cooled down faster in 180 seconds?
Beaker B.
Beaker B or 100 cm cube. So we can say that rate of a cooling, like if a amount of a liquid is small, like if we have a smaller volume of a liquid, then it will cool down faster. And how we can justify? We can justify like in 180 second, the 100 cm cube beaker or 100 cm cube of a water shows a temperature change of 14.5, where for beaker A, which consists of 200 cm cube of water, only changes the temperature by 9.5. You have to justify your answer by reference to the result. So what conclusion? Stating how the volume of a water. So what we can say? So rate of a cooling.
The lower the water volume, the more the temperature change.
Yeah. So we can also say like rate of cooling is inversely related to volume of water. If we have a smaller volume of water, rate of cooling is higher. So 100 cm cube shows a temperature change of 14.5. And 200 cm cube, what was the temperature change? 9?
9.
9. So what it shows that rate of cooling increase when the volume decrease. And both we took in 180 seconds. So you will mention in 180 seconds the rate of a cooling for 100 beaker A. This was beaker A and this was beaker B. The next one, use the results for 100 cm cube of a water, calculate the average rate of a cooling in first 90 seconds and then other 90 seconds. So first 90 seconds for 100 cm cube. First 90 second, what is the rate of cooling? First 90 second, like change in temperature divided by time. What is the change in temperature in first 90 seconds?
8.5 degrees.
So 8.5 degree and divided by what is the time? Time is 90. So 8.5 divided by 90, what's the answer?
0.094.
0.094 degrees centigrade or Celsius per second. And what is the rate of a cooling in remaining 90 seconds, like from 90 to 180? What's the temperature change here?
6 degrees.
So the temperature change is 6. And how much time? Again, 90. So 6 divided by 90, what's the answer?
0.06.
So 0.066 degrees centigrade per second. So as you can see, rate of cooling is also not constant. In the beginning, when the temperature of a water is higher, it cool down faster. But when the temperature of a water decreases, the rate of a cooling also decreases. Means when the liquid is hot, it will show a greater change in temperature in the same time interval as compared to a liquid which is at lower temperature. So here you just have to mention the rate of a cooling. Temperature at 0 and 90, when you take a difference of that, it was, we just did now. It was, the temperature change was 8.5 here and this was 90. So we got 0.094 and degrees centigrade per second. And this was temperature change was 6 and the time interval is 90. So we got 0.066. A student suggests that it is important that this experiment with two volume of a water should have a same starting temperature. State whether your value of x1 and x2 support this suggestion. Like students suggest when we are comparing this result, we should have the same starting temperature. Like if a starting temperature of this one is say 87, this should also be 87, but it is 89. So does it affect the result? Yes or no? If the starting temperatures are different, will it affect the result?
Yes.
Yes.
Yes,
Because
it will affect.
yes, it will affect because you can clearly see when the temperatures are different, the rate of cooling also affected by temperature. So statement you will say yes. And the higher temperature, greater rate of cooling. Otherwise, if the rate of cooling, or you can also mention that rate of cooling is also affected by the temperature. So higher temperature has greater rate of a cooling, as the value of x1 and x2 are not same. Because if rate of cooling is not affected by temperature, then the value of x1 and x2 should be same. Another student planned to investigate whether more thermal energy lost from water surface than from the sides of a beaker. Like student want to investigate like whether more energy lost from surface or sides of a beaker. Describe an experiment that could be done to investigate this. You may draw a diagram. So student want to investigate like whether like more energy lost from surface or more energy lost from sides of a beaker. Sides of a beaker, how we can, so what he should do? He should do the experiment, or he should perform the
So,
experiment.
Mr. We can put like a thermometer at the side and thermometer into the beaker.
No, instead of that, because first what you will do, you will use a lagging or insulation in the side and keep the without lid. No lid is there, and you record the temperature change. This is for, so using this, you will investigate. So using this, you can investigate how the surface area or area is affecting the rate of cooling. And then what you will do, you will repeat the experiment with the same beaker with a lid, but without insulation. And you will compare the results. Because this one, when you keep the surrounding, when you keep the insulation in the surrounding, and it is like having no lid on it. So what you're investigating the energy loss from the surface or heat loss from the surface. And when you place a lid and the wall, there is no insulation. Now you are investigating how the energy dissipate or loss from the surrounding or the walls or sides of a beaker. So what we simply do, we'll do the experiment with the lid, with no insulation, and then we'll repeat the experiment with insulation without a lid. So the answer here to compare, like, because if I want to investigate which one affect the rate of a cooling more, is the surface or the walls. So what I should do, I should do this experiment, or I should repeat this experiment with insulation and without lid. And then I will do the experiment without or with lid and without insulation. And then I will compare the results or compare the temperature changes. And the one which show a greater change in temperature, that is like have greater amount of thermal energy lost. Is this clear? This experiment?
Yes, sir, clear.